Hello all. Today we discuss about 8085 programming lessons. So in this topic we discuss about 8085 programming example. First of all, here we discuss about the programming method of 8085. Now let us consider first programming. Our first programming is 10 8-bit numbers. 10 8-bit numbers store from memory location 9000. Okay, say for example, now our task is to check whether the number is equal to 0. If 0, then count this number of zeros between these 10 numbers. Okay, say consider here 9000. The first number is located, second number is located, third number, fourth, and last of the 10th number are located. That is from 900 to 9009. 0 1 2 3 4 5 6 7 8 9 10 numbers are stored from starting location 9000 hex to 9009 hex location, memory location. Now search from this number and check whether the number is 0 or not. So for this type of programming, first we initialize our counting, that is mvi b comma 0a, and for number of zeros count we store mvi c equal to 00. So that is c register equal to 00 to store the count value of number of zeros. Now first our initialize lxih 9000 and go to the accumulator first. Now one thing should you remember, the accumulator is basically or itself with accumulator. That means here we a or with a, that is stored in the a. Now if the number is 00, then 00 or with 00, that produce the 0 flag equal to 1, and if the number not equal to 0, then the 0 flag is not set. Okay, so this is the our main key of this programming, to check the number is 0 or not. So now after this or a operation, we check jump if no 0. Okay, now if jump if no 0, no 0 means the number, if the number is, yes, right, the number is not 0. So now we decrement this register. Which register? B. Now check this register is 0 or not. If this register is not 0, and then we again come back to here. One thing should be remembered here, after decrement B, before decrement B, one thing should be remembered, before decrement B we should be increment the pointer, because for the next number location. Okay, then decrement B, then if not equal to 0, then we come back to again L2. L2 means from here. Okay, and if this jump if no 0 is false, then that means 0 flag is set. Yes, right, then we increment the C. Okay, and then INXH, then it's follow the next flow. That means INXH 8 next, and then decrement B, and then JNZ. Okay, now here our count is stored, if how many zeros are stored here. Okay, so now after this the loop is end. Now move this value in the accumulator and store, say for location 900A. So here in the 900A we see that how many zeros are, and next halt is executed. So here 900A we see that how many numbers or zeros are stored. Now let us check about it. So now, okay, now this is our 8085 simulator ID. Here I open the assembler first, and here I write the code properly, step by step. So now in a caps mvi b comma 00a hexadecimal, then mvi c comma 00 hexadecimal, lxi h comma 9000 hexadecimal, then move a comma m, then aura a, then change it L1, then increment C, then here L1 is placed, and after L1 INX age is executed, then DCRB is executed, then change it L2, then move A comma C, then STA 900A hexadecimal, then halt is executed. Now here changes L2 is basically goes from here to here, from here to here. Okay, so now check it properly, is it okay or not? MBI B C, all things are okay. Okay, now we assemble and load. Okay, there is no error, you see that. Now again this is checking this MBI B comma 0A C comma 00, let's say H, then A comma or I change it, and C INX H decrement B, change it L2, and so on. Okay, now our task is simulation. Before start the simulation, you open the memory editor. This is our memory editor, and here from the 9000 we store our number. 10 numbers are stored one by one. So here 10 numbers are stored, 1 2 say 3 0 0, then 2 5, then 2 6, then 0, then again 0, then 0 0 and 0. Okay, so that is there are 1 2 3 4 5 zeros are placed. So after the programming, here 5 is shown. Okay, you see that, is it okay or not? Now start the simulation. Okay, it's running. After the running, yes, right here show that these are 5. So next, for the next number, for 0 45, say for first is 4, and then 12, and then 45, then 00, then 45, then 89, then the 25, then 00, then again 25. Okay, now see that here 2 zeros are located. Okay, now, oh sorry, here one number is extra, one number, there's 2 zeros. So before this, sorry, before assemble and load, and then again we enter this number, sorry. Okay, 1 0, second 0, 2 5, 5 6, 89, say this is 33, and enter. So here answer is equal to 2. So see that, is it okay or not? Okay, now see that, yes, right, it is okay. Okay, now student, you please check the another array of numbers inside here, and to check how many zeros are contained in this array of these 10 8-bit number are stored from 9000 to 9000. Yes, right, 9009 hex memory location. Okay, so this is the array programming, where we count the number of zeros. How many number of zeros? Okay, one thing mentioned here, if the programming is just opposite, that is, check here, we check the number of zeros, and if we check the number of non-zero numbers, then what we can do, then our task is, here we jump if no zero, that means here we jump, then here we return jump if 0, then if jump if 0, then it is jump to the next location INXH, and that means jump if 0 means if the number is 0, then if the number is 0, then this is not counting, that is C register is not updated, it is jump directly here. And if the number is non-zero, then it is counting C equal to C plus 1. Okay, okay, now check it, is it okay or not? Now check it here, only just change for non-zero number in the array, how many number are non-zero. Now check it here, we insert say 1 0 2 5 0 2 5 6 5 0 0 0 0. Now check it here, non-zero number are 1 2 3 4 numbers. Okay, now is it okay or not? Check it. Here problem arises, here one problem arises because in the array store here the result is not shown. Because why? Because, oh sorry, just a minute, here in this jump, extremely sorry, in this loop we just change this, and now, okay, first of all are zeros. So see that how many numbers of non-zero number. So basically there are no non-zero numbers, so basically this is a 0. So now how can check it? Now again assemble and load. Then now from here 45, one number is placed. So how many numbers? One non-zero numbers, that is 45. what is counting is just that, yes, this is 1. Okay. So now here we insert 89, say 78, say 78 again. So how many numbers are non-zero? 7 numbers are non-zero. So see that it is okay or not okay. Okay, now is it? Yes, 3 numbers are non-zero numbers. So in that way, in this process, you can check, you can take in another array of numbers and check how many numbers are non-zero. So just here in this loop, just decision of depending on the zero flag, we can change our decision or change our loop sequence to determine the non-zero and how many zero and non-zero numbers. Okay, so this is the edge-related programming. In a edge-related programming method in the assembly language, we can check for any dimension of array. I consider here 10 numbers of array. You can check also 20 number, 30 number, 40 number. So this is a very important for to check the zero numbers in the array or non-zero numbers in the array. Okay, now we discuss about 7 segment display code without decoder IC. That is, we already know that in the previous lecture 7447 is a driver IC of 7 segment display. But if we not use this driver IC, then we can send the number, hexadecimal number, from the microprocessor or via peripheral. But first of all, what is a display code? So there are 2 types of display are available in the market. One is common anode type, one is common cathode. But in this lecture, we discuss about common anode type. And the segment name is A, B, C, D, E, F, G, and this is the decimal dot notation. So here we write A, B, C, D, E, F, G, and H. So now here we write our hex code. Okay. So now for common anode type, we know that if 0 is shown in this display, so when 0 is displayed, so these LEDs are glowing. So for glowing this LED, the logic 0 is applied here for common anode display. So here the segment name is A, B, C, D, E, F. Okay, for 1 there are 2 segment are glow. For 2 there are A, B, D, A, B, C, D, E, F, and G. For 3 there is A, B, C, D, E, F, and G. So now first write A. For A there is all 0 except equal to G, and if you show that decimal dot notation, so here apply 0, otherwise it is 1. So for 1 the BC will be only 0, so that means this will be 0 and other bit are equal to 1. Okay, and this equal to 0 for dot notation. For 2 there are A, B, D, E, G. A, B, D, E, G, that means A, B, D, E, G, and remaining bits are on H equal to 0. So now if we take partition of the phone number 4 bit, because hexadecimal notation, so this is 0 and 2. So this is a 0 to code, hexadecimal code to showing the 0 in this display. This is 9, this is 109, and this is 9E to show the 1 in the display. This is 2 and this is 424, and follow this and to follow the same manner, we show the 3, 4, 5, 6, 7, 8, and 9 up to 9. We can show our hexadecimal code. So student, please do it yourself. I just mentioned here for 0, 1, 2, and it is your home task to calculate the hexadecimal code for the another numeric display, let's say for 3, 4, 5, 6, 7, 8, and 9. Okay, these are